we're starting today doing multiplying real numbers.
Yay.
Quizzes. They're not graded because not all of them are complete. Has everyone taken the quiz in this class?
I think so.
Just him, who's gone. Not all quizzes have been taken, so I don't grade them until I have them all, just because of the way I am. You call it OCD, whatever you want. I don't like grading quizzes until I have them all, or maybe just one or two missing. So I have more than one or two that haven't taken it. So hopefully I can get those done today. That way you guys can have those tomorrow. Alright? So after the quiz though, you're supposed to read a little bit about this section. Now, depending on how far you got, we'll tell kind of how the day goes. Alright? So you guys have all multiplied numbers, correct? Sure. This isn't your first rodeo with multiplication, like your seventh. Alright? Well, when you multiply numbers, how many numbers do you usually multiply at a time? 2. Okay? So this is situations of 2-number multiplication. Situations of 2-number multiplication. Alright, well, there just so happens to be 4 situations. Okay? Do you guys know, or do you guys understand when I say situations? 4 situations. What? Okay, there we go. We're talking about the signs. Alright? So Gloria said positive times a positive. Well, Gloria, when we do positive times a positive, what do we get?
Positive.
We get a positive number. You guys know that. That's what you've been working with since the 3rd grade. Positive number times a positive number, you got a positive number as a result. You guys give me another situation? Grading? Positive times a negative. Well, what do we get as our end result? Grading? Negative. Good. What's another situation? Did you go?
Negative times negative.
Negative times a negative. And that equals what? Did you go?
Positive.
Positive. Wahoo. Good. What's my last situation? What's my last situation? Michelson, what's my last situation? Ooh.
I don't know.
Yeah, you do. What haven't we done yet? We've done positive times a positive, positive times a negative, negative times a negative. What have we done yet?
I don't know.
Trey, help her out.
Negative times positive.
Negative times a positive.
just switched around.
Possibly, let's just hold that.
Possible.
What is it? A negative.
Told you, Trey.
I knew the answer.
What's the same?
They're different.
It's the same thing either random. Or you can do either or, I guess.
What about 0?
Indeed, you could.
Anything times 0 is
Zero.
We have negative.
There's no such thing as a negative 0 or positive 0.
Positive.
Okay? Good. Well, you guys have done two-number multiplication for a while now, so let's step it up. Let's take it to the streets. The streets of Huxley.
That's
Oh,
streets right there.
What do we have?
Okay.
0.3.
So -3, 4, -6, -5. That is a mathematical statement up on the board, correct? What type of mathematical statement is that? That's what's going on in there. What type of statement? An expression, an equation, or an inequality? Madison? Numeric, okay, numeric is right. Numeric what, though? Which one? Expression. Why is it a numeric expression? There's no equal sign and there's no inequality symbol, okay? Little review. Alright, good. Now what are we doing? Are we solving, simplifying, or evaluating? What are we doing?
Evaluating.
Evaluating. Why are we not solving? There's no variable. Okay, when you solve, you're trying to find the number for the variable. Is there a variable in here?
No.
So we're evaluating. So this says evaluate this process right there. Well, what's the process we use? Raise your hand. To cut chicken.
Count that.
What's the process we use to do evaluate? Dakota?
Order of operations.
Order of operations. Good. Well, what comes first in order of operations? Parentheses. Palmer. Can I do anything with the parentheses right now?
Nope.
Because what is it, when they say parentheses, what are they wanting you to do? Whatever's inside. They want you to simplify inside. Well, can we simplify inside any of these parentheses?
No.
No. So after parentheses comes what, Newell? Exponents. Are there any exponents in this?
No.
No. After exponents, Becca, what do we do? Multiplication. Is that it? So, is it just multiplication? After exponents? It is? Thought so? Is it just multiplication?
No.
And division, right? They're in the same group. Why? Because we have to work it from left to right for you guys. Left to right. Good. So, who do I start off with? -3 times 4. Now, what's going to be our result sign? Because negative times positive is a negative. So I can just do 3 times 4 now, right? What's 3 times 4? 12. So what type of 12 is this going to be?
Negative.
Good. I bring down the -6. That's what's next. What's my final result going to be for these next two numbers?
Positive.
Positive. Okay, well, can't use a calculator, not allowed.
72.
So I'd have to do it the old-fashioned way if I wasn't a brainiac like Fitchko. So I'm multiplying. I do the 6 times the 2 first, right?
Yeah.
I get 12. I just write 12 right here? What do I do? Leave the 2 and then carry the un. Then I do 6 times 1. What do I get? Add 1. So my answer is 72. And in order to determine, it was going to be positive. Then I have this guy.
Negative 360.
Well, the first thing you decide is what? What the sign is going to be. So what's the sign going to be?
Negative.
Negative. I know it's going to be a negative. Well, if I do it the old-fashioned way again. Oops.
Yeah, paper. I can't.
Oh.
Because you cannot use a calculator. 5 times 2. So leave the 0. Carry the 1. 5 times 7. Plus 1. Good. So my answer is negative 360. Not too shabby, right? Okay, question?
Can you just multiply the negative 3 and 4?
How do you know this?
Can you just do this together?
Go left to right. I want you to go left to right. Okay? We'll talk about this another day.
Okay.
I want you to come up there right now, okay? So, question. I want you to answer this question in your head, not out loud. Could you have determined what the final sign was going to be before doing any of that work? I don't want you to look at anybody or give them the answer. I just want to know, in your head, could you have determined what the final sign, this guy, was going to be based on what we had here?
Yeah.
No! In your head.
Oh,
In your head.
Homer.
Alright? Now, for those of you who think you can do it, just shake your head yes. I can figure out the sign beforehand. Okay? So, here's your next problem. You're going to evaluate 3, 2, negative 4, 2, negative 3. Now, before you do this problem, I want you to write off to the right, or wherever you're doing your problem, I want you to write what you think the final sign is going to be. Okay? Before you start evaluating, I want you to decide what's it going to be. Once you've decided what it is, what you think the final sign will be, go ahead and evaluate. Okie dokie. I apologize. What did you guys determine it was going to be? How did you know that? How did you know this value is going to be positive? What is the general rule to determine? Palmer?
2 negatives equal positive.
Okay, well, I already knew that. But that was for just 2 numbers. There's 5 numbers there. Grading?
Even amount of negatives.
Ah!
Even positive, and you got 5 negatives,
Even amount of negatives, negative numbers equals a positive value. So Palmer, you were right, but I was looking for that number even. Okay? Well, what's going to tell me if I have a negative number? Odd amount. Odd amount of negative numbers. That's going to equal a negative value. Okay? So we know this one's going to be positive, right? So, do I really care about the negative numbers in that problem anymore? No, I can just do the multiplication of all the positive. Right? I can do 3 times 2. What is that? 6.
That's why I am wrong.
And then I can do 6 times 4, right? What do I get? 24, right? Why don't I need the negative anymore? Why does this negative not affect me anymore?
It's already on there.
Because I already know my final answer is going to be positive. So I can just go ahead and multiply all the way through. If you put this before you work on it, this counts as good work. But if I don't see this and I see this, then I'm going to think you're doing it wrong. Okay? So I want to know you're putting positive or negative before you even start the problem. And then you can just go positives all the way. 24 times 2?
48.
48 times 3? 144. We already know it's positive because of that guy right there. Correct?
Yeah.
Are there any questions on what we just did there? We have just evaluated numeric expressions. Alright? Now we're going to evaluate algebraic expressions. Now, what makes an algebraic expression? What are the parts to an algebraic expression? Raise your hand. Meldrum, give me one. Variables. Give me another one. What's another part of an algebraic expression? No. An expression. Remember, an expression. You said this earlier. Does it have an equal sign? No. So I've got variables. What else is in an algebraic expression? Numbers. Right? And there's one more thing.
The thing, multiplication thing.
What do you call multiplication? What do you call symbols?
Sign of operation.
Not order, but just operations. Okay, so numbers, variables, operations. That's what makes up an algebraic expression. So we're going to evaluate an algebraic expression. And what's the process we use to evaluate an algebraic expression? Louder.
Order of operation.
Paul.
Order of operation.
Louder.
Order of operation.
That's not any louder. Just changed your tone.
Order of operation.
Order of operation. Oh my goodness. So, we're going to evaluate this expression. Negative n squared plus 9. Evaluate. Go. What do you need, Kennedy?
You know what that
We got to know what n is in order to evaluate. Well, when n is equal to negative 3. So, don't get ahead of yourself. Hold on. What do we do? When you're evaluating an expression, an algebraic expression, what do? First, what's your first step over?
Substitute.
Substitute what? The number for the variable. The number in this case is? Okay, well what's our special buddy we use when we substitute? Parentheses, or some sort of grouping symbol. Okay? Well, is it like that?
Oh, no.
What am I missing, or do I have too much? Where does the negative go? Ah, okay. This is a negative n. Well, what is n? So it should say negative 3, right? Okay, good. Well, again, what's the process that we're using to evaluate. Order of operations, right? And that's please excuse my dear Aunt Sacagawea. Let Lewis and Clark. See, cross-culture, cross-curriculum right here. Right? Louisiana Purchase. Anyways, you guys are really excited about history, huh? What do I do first?
Parentheses.
Okay? Can I do anything in the parentheses? Then what do I do?
Then you should,
Exponent?
I agree.
But this is opposite, right? Opposite of -3. Where does opposite fall?
I don't know. After you do exponents. After you do
That's where it says,
exponents.
please excuse opposite my.
what?
How do you guys know I'm not supposed to do opposites at the very beginning? If you have something to say, please raise your hand. Shouldn't I do opposites first, Sitchko? Bitchko?
I don't know, but wouldn't they cancel out?
So you're saying use the opposite first. Do the opposite of -3 first, right?
No, because, well, when you're answering.
Where does it say when to do
It
opposites?
doesn't.
Please excuse my dear Aunt Sacagawea.
It doesn't say.
So then what do we do? What? Well, I need an order.
We don't know.
Well, that's the problem.
Skip the problem. And
No.
ask your teacher later.
That's
You're
good.
fine. I have a question for you. Okay, we're going to take a step to the side. Okay, so we're starting here. Here's the problem. Step to the side. I've got the number 4. Logan, what is the opposite of 4? Right? How can I show that using a mathematical operation? How can I show that using a mathematical operation? Graded?
Put it before the parentheses, put it in negative. Before the parentheses and put it in.
No, I want an actual operation. Your actual operations are division, multiplication, subtraction, and addition.
Multiplication.
Multiply by -1 or -8. What is always going to work no matter what number you use? Multiply by what?
Well, 1 for.
4 times 1 is what? Does it equal -4?
No.
So what does this one need to be? Okay? What's the opposite of -6, Madison? What's the opposite of -6? 6. How would I get that? Would I multiply by 1? What would I multiply by? -1. There's a dot there. Here's 5. This says the opposite of 5 is -5. What is missing right there? Belgium.
The times -1.
Well, not necessarily. What is invisible? The 1. Where does the 1 go?
Right by the parentheses.
Right after the negative, right? Anytime there's a number next to the parentheses, what does that mean?
Multiply.
Multiply. Aha! Step back. What is missing in this problem? Where? Right after the negative. So what do we do first? Exponent. So now do you know what you have to do first?
Yeah.
You have to do the -3 squared. Because why can't we do the opposite? What operation is the opposite really mean? Multiplication. And who, Trey, does multiplication come after? exponents. So that's what we got there. So, negative 3 squared really means what? Negative 3 times negative 3. So I have negative 1, parentheses, negative 3 times negative 3 plus 9. Well, a negative times a negative is a what? So 3 times 3 is? So it's a positive 9. So negative 1 times a positive 9 plus 9. What's negative 1 times 9? Negative 9. Negative 9 plus 9 is? Easy, easy, lemon squeezy. Now does it make sense? Multiplication. Okay?
So we have to add the 1 also.
I would do that to keep yourself organized. Okay, to let yourself know that's multiplication. I can't do that part until I do my exponents. Okay?